Good afternoon, everyone. Oops. Hold on just a minute. We have two computers too close together. Okay. Welcome to our monthly speaker meeting. You'll see on your screen right now our current sponsors are the Belize Ag Report and the Bluff Restaurant. Today's talk is given by William Usher, and it's all about potting soil, mulch, compost, and Bokashi. Some of you have probably seen William on our speaker meetings before. He was doing one exactly the same time last year in March, and he's always such a wealth of information that he shares with us. So get ready. Okay, just a couple of ground rules for any of you who have not attended our meetings before. The meeting is being recorded, so if everybody will please stay muted. That way it knocks out any background, chatter, dogs, etc. So if everybody will please mute yourselves for the rest of the meeting. And we will have a Q&A after William's presentation. So what you can do is during his presentation, as you think of questions, then see it. Then if you will submit them to the ProOrganic host in the chat session. And then at the end, at start of the Q&A, I'll just start reading the questions off. I'm going to pause for just a moment because I don't think anybody's hearing me.
Yes, we are.
You are. Okay, great. All right. Thanks, William. Okay. So submit your questions as we go along to the ProOrganic host. And then I'll read them off to William during the Q&A. Just a quick introduction to ProOrganic Belize. You can find all kinds of information about our group on our Facebook page for more details about us. And there's the website for that. And then our Facebook group is that we use for discussion. So you can also see past speaker meetings, just kind of current things going on with our group. And about our organization, I recommend you go to pro-organicbelize.org and you can see information about how to join our group. Current dues are due for 2022, which on a yearly basis, $25 a person. And then you can also get information about our current consumer group, which what this is you get on a list and you get a weekly list of pesticide-free produce and how you can order this. There's two places right now for pickup. One is at Hody's on Friday mornings in San Ignacio, and the other one is at the Blue Moon Market in Belmopan, also on Friday mornings. So it's a great way, especially now that we're hopefully starting to come out of some of these lockdown things. But to continue and to start for some people eating more healthy by getting pesticide-free produce. Very, very important for us right now. Okay, our meeting topic, as I said, is about potting soil, mulch, compost, and Bokashi. William Usher, he's the general manager of BAEL, and I'll put up a slide later with his phone numbers and contact information, email. He's located in Belmopan. Some of you are probably familiar with him. He's been around for a good long time. And from what I hear from Mary, he plans to be around for a very long time. So again, submit your questions in the chat session. And we will get started with William. So it's all yours, William.
Okay, great. Good afternoon, everyone. Um, I I was the topic that was given certainly is very large. Each one of those stuff could take half an hour to an hour. And so for this presentation, I won't be going in detail, a whole lot of detail in each of these, but more so just stating what it is. And I want to have at least 10 minutes a demonstration to show how we make PM Bokashi towards the end. So the presentation should be taking about 25 to 30 minutes and another 10 to 15 minutes with the how to use to make the bokashi and how to use it as well in terms of your home food waste. And in general, that would be it. Of course, being that we are the manufacturers of effective microorganism in Belize, my take is always slanted in that area, in that it certainly is beneficial to the areas that we are speaking of. I personally don't have a problem if we can interact with each other, but if we need to ask the question afterwards, that's quite fine as well. But I'm open if anybody need to ask question right away. That's quite okay with me. So to start, I will just share my screen. Okay, for some reason, the host have to give me access to share. Yeah, I still can't share. Okay, okay, now that's great. So my contents. Okay, I'm looking for my pointer. Just give me 1 minute here. Okay, everybody seeing the screen? Nobody answered?
Yes, yes.
Okay, that's great. Um, as the headline state, potting soil, mulch, compost, and as I said, I will speak EM Bokashi. In the reality is Bokashi actually means fermented organic uh, material in Japanese. That's the actual Japanese name, Bokashi. And it's using EM in this case, the trademark product. My name is William Usher. I'm an agricultural engineer by training. I am the EM technology expert and representation of EMRO, Belize Agro Enterprise Limited in Belize. My area of work and expertise is in soil and plant nutrition and sustainable agriculture. I am the general manager of Belize Agro Enterprise Limited. That's what the BAEL means. Normally we say BAEL. People say bail, all kind of stuff, but you take it how you want. It's Belize Agro Enterprise Limited. Um, starting off, there is always concepts and fundamentals that we have to look at when we doing any presentation. And in this case, the goal is to understand why we mulch, why use EM compost, why Bokashi, and why a good potting mix or soil mix is important to a song crop production management. And of course, the objective of the session is threefold: to discuss the purpose of mulching, composting, and having a good potting mix, learn the differences between traditional compost and EM compost, and learn to make and use EM Bokashi. As I say, I will not get into a whole lot of technicalities of composting, etc. I truly would like to get into that on a whole nother presentation by itself at another time, because you could spend a whole hour, 2 hours, depending on who we are speaking to. And simply, I believe we are speaking to a lot of practical people who wants to use the technology to improve upon their gardening and their crop, etc., and their soil, and basically using technologies that is available within the specific area, in this case in Belize, no, and where our technology lies, CARICOM. So to continue, for us as Belize Agro Enterprise Limited, everything we do surround trying to improve or address the challenge ahead for farmers, right? And we know that that is really to produce more food on a declining land area, with soils and ecosystems that are continually being degraded, all while using less water, energy, and natural resource under difficult economic circumstances. And that's what exists today. And the reality, the topic basically is the, the different components are technical components that plays a role in trying to address these challenges to farmers and producers. And so it's very much in line with what we as a company, Belize Agro Enterprise, do. Here, you'll see a tree, no? And this is actually, okay, representation, it's a tree. There's a above ground part, there's a below ground part. And normally we tend to be looking just on the top, while the reality is everything is happening at the bottom. And my first issue there is say, we are what we eat, right? I borrowed this slide from our EM producer in Peru, which is very, very nice slide to show basically that soil fertility is one of or the most important thing in terms of your crop growing. And when we are talking soil fertility, there are three components. We are talking the physical fertility of the soil, the chemical fertility of the soil, and the biological fertility. And these topics that we are going into in terms of the biological fertility, where we are talking Bokashi. Bokashi, we are actually talking fermenting organic material using microorganisms. So we are bioremediating soils. We are also talking organic matter that we are fermenting. Same thing when we are doing compost. That's basically we it's not fermentation because it's not anaerobic, but it goes through a process of decomposition. But it's the physical fertility that we begin to address. Then we have the mineral fertility, which is the the fertilizers, be it biological or chemical, and our good topic over here, which is the mulch. As you see that green layer on top, that's basically what we are talking about. But with all of this, there has to be a technical management, and all these things are intertwined, and it all depends how you are managing these. Which will allow for improving what we call the soil biological web. And with that, uh, we start talking about improving the economics of what we are doing, improving the social aspect of what we are doing, and obviously the environmental component. So take these into consideration, because this is what we'll be looking at. And to start, this is in Spanish, but basically what it's saying by FAO, and they continue saying this in all their annual international soil presentation, for people not to forget that there are far more organisms or microorganisms in 1 tablespoon of soil than the whole population of the Earth's planet. We are like 7.4 billion. Within that 1 tablespoon, there is over two, 200 billion microorganisms. And it shows how important they are uh, to all we do. That's why we talk about we are what we eat. No? And as we are talking about microorganisms, this is just a basic thing that we need to understand, the important function of these microorganisms in soil, microorganisms in general. Uh, but one of the important part is that they mineralize organic matter. What that means basically means it breaks down that organic component, or that fruit or vegetable or whatever you're throwing away from your house, and it breaks it down into the different components of nutrients and organic acids and amino acids and other stuff. That's basically what microbes does. That's why we are talking about inoculating these food waste with microbes. Uh, Many microbes are nitrogen fixers. They fix nitrogen. In other words, they capture nitrogen from the soil and basically from the air, sorry, and converts it and allow for the plant to use that nitrogen and brings it into the soil itself, like the rhizobium and Nitrobacter and Azotobacter and these type of nitrogen fixing bacteria. They are also root growth uh, promoters as well, in that they actually produce different hormones. They produces enzymes and vitamins as well. Very important part, which is a part that we'll talk about, is that they allow for soil aggregation and stability. In other words, these microorganisms are the sole basically responsibility, along with to bring, say, if we are looking, say, sea sand in time, to be able to be that what we call black dirt in Belize. It's microbes responsible for those conversion, and it does it through soil aggregation, etc. But they produce phytohormones, other hormones that is responsible, say, for photosynthesis within the plant. that the plant makes its food. They also play a major role in absorption and translocation. That is a movement of minerals within the plant, within the soil. They also chelate minerals. In other words, making minerals available or protecting the minerals and not allowing it to go to waste or say to be volatilized or basically get washed down. As minerals chelate, it's easier for them to move into the plants. And of course, mineral solubilization, that's another important role and function of microbes in that they actually break down uh, rocks and find those minerals that are within them, allow them to become available to the plant. Uh, and importantly, in the technology of EM, basically all of that happen with all the different microbes, be it directly or indirectly in association with natural microbes within the soil. There are two presentations I actually want to do here. There are videos from Dr. Elaine's Soil Food Web School. And this is important for us to understand, no? Why is it important to have well-structured soil? It might sound like I'm going into an issue of soil, but it's actually microbial issues and the whole concept of why the compost, why the mulch, and all these things. My problem here now, I know I can't go directly here, so I believe I have to stop share, and then I will go and get these two videos and then share again. Because I don't think it will happen from here. So I'll stop share. And I supposed to be able to go to the, I'm not sure if you guys are seeing. Are you seeing what I'm doing? Okay, let me go back and share my screen. Share Chrome. Are you seeing?
Yes.
Okay, good. That's how it works. I remember from the last time I was having problem here, but it works. So if you look at this website, it's really a good website to go to for those who want to understand the quick basics. It's cartoon and you really understand what's going here. So I will let the video speak for itself, and then we could ask question at the end if necessary. But there are two of these videos I want to show. The first one, the soil food web, and the third one that is on the right that you see the numbers on. These will take about 12 minutes, but it's very important for us to listen to them. So here we go. No audio? Okay. How do we get the audio?
Is there someplace on your screen on the video itself that has audio off or on?
Just a minute. Let my technician.
That some members of the food chain don't just eat one thing. That goes for humans too. So the reality is more like a web than a chain. This is the food web. There happens to be a food web in the soil too. This is the living part of the soil made up of insects, earthworms, and much smaller microscopic creatures such as fungi and bacteria. Dr. Elaine Ingham has pioneered research into the microorganisms in the soil over the last 4 decades, and has worked with a team of research scientists to understand how they interact with each other and with plants. The soil food web can be thought of as the soil biome. Just as humans have a gut biome responsible for digesting our foods, so too the soil has a biome, which breaks down organic matter and releases nutrients in plant-available form. This is how nature has been feeding plants for billions of years. The major groups that make up the soil food web are bacteria, fungi, protozoa, and nematodes. When in balance, these different groups interact with each other and with plants to create abundant ecosystems such as the great forests of the world. Have you ever wondered how forests can be the most productive ecosystems in the world without the need for any fertilizers or pesticides? The answer lies in soil biology. With a healthy biome, the soil can provide plants with all the nutrients they need, and with a number of other benefits, such as protection from pests and diseases, protection from drought and from flooding. The soil food web is, essentially, nature's operating system. Unfortunately, we humans have disturbed the soil food web in almost all of the soils that we manage, causing it to become unbalanced. As a result, the plants we grow struggle. Plowing is the major cause of the problem, as it destroys the larger microorganisms, such as fungi and protozoa, leaving the soil food web out of balance. This results in a system breakdown. Nutrients are no longer made available to plants, and protection from diseases is compromised. Before the Industrial Revolution, humans would plow using oxen or a bull, which provided around 3 or 4 horsepower. Modern tractors can yield 400 horsepower or more. So far more damage is done to the soil biome by modern machinery. The use of chemicals has compounded the problem. The good news is that we can restore the soil food web to most soils within just a few months. This results in a number of benefits, both for farmers and for the environment. With a balanced soil food web in place, farmers need not use fertilizers at all. They don't need to use pesticides either, as nature's operating system protects plants from attack. Herbicides, used to kill weeds, are not required either, as weeds only thrive in conditions where the food web is out of balance. Restoring the soil food web means farmers save money on chemical inputs across the board. It also means that their yields increase dramatically. In some cases, farmers working with Dr. Elaine Ingham have seen yields increase by over 200%. This is because the soil food web provides plants access to a constant flow of nutrients from soil organic matter, and from the soil particles themselves. That's right, sand particles contain nutrients, and guess what? Fungi and bacteria can harvest those nutrients. They then make these available to the plant in a process that the plant actually controls. This means that plants get access to the type of nutrients they need precisely when they need them. That's how you maximize yields and optimize profits. For the environment, there is a whole host of benefits of having a balanced soil food web. Humanity is facing a number of existential threats. Let's take a look at how some of these are related to the soil. The most obvious one is soil erosion. The United Nations Food and Agriculture Organization has estimated that we only have around 60 years left before all the world's topsoil is depleted. Other estimates are as low as 30 years. The soil food web prevents soil erosion by both wind and water by building structure. Please watch the animation on soil structure for more information. Another existential threat we are facing is ecosystem collapse. The UN has recently stated that insect populations have been decimated by around 25% each decade for the last 30 years. That means that there are 57% less insects today than there were in 1989. Bird populations have declined by 1/3 in the last 15 years in parts of Europe. So how does the soil food web help? Well, the UN has identified the use of pesticides as a major cause in the decline of insect populations. Please watch the animation on pests and diseases to find out how nature's operating system protects plants against attack, eliminating the need for pesticides. Another threat to life on Earth is climate change. Fortunately, the soil is capable of holding tremendous amounts of carbon in the bodies of microorganisms, and some mega-organisms too. The biggest living organism in the world is not a whale, it's a fungus found in Oregon that is the size of 1,665 football fields. It is between 2,000 and 8,000 years old, and it is made mostly of carbon. By restoring the soil food web, we could put a stop to climate change. Please watch the animation on soil carbon sequestration for more details. At the Soil Food Web School, we train people like you to help farmers transition away from using chemicals to farming in harmony with nature by restoring the soil food web. If you would like to join the soil revolution, then sign up for the foundation courses today.
So I now go to the other one, that the formation of structures, and this is where composting plays a major role. The mulching plays a major role. But it's important for you all to understand how the formation, how the structures are formed. And again, without me have to talk for an hour, this little video does it in about 5 minutes, and it gives you the right pointers right away. So we now go to that one.
Why is it important to have well-structured soil? A well-structured soil will allow water to gradually flow through it. As the water passes down through the soil profile, it creates a vacuum, and so fresh air is drawn into the soil, thus creating aerobic or oxygen-rich conditions. This is crucially important, as the majority of disease-causing microbes cannot operate in oxygen-rich environments, and they are forced to shut down. Meanwhile, beneficial microorganisms thrive in oxygen-rich environments. Water droplets are held in the numerous cracks and crevices, and in organic matter for long periods of time, thus increasing drought resistance. Good structure allows plant roots to move effortlessly through the soil profile without having to work hard against compaction layers. In soils where good structure has not been built by beneficial microorganisms, compaction layers are easily formed by vehicles, by human and animal traffic, and where the soil surface is left bare by rainfall. Compaction layers force plant roots to grow sideways, limiting their access to nutrients and water. When plant roots break through compaction layers, they encounter anaerobic or low oxygen conditions. Those are occupied by anaerobic microorganisms, which produce highly acidic compounds. Roots cannot survive in such conditions where the pH can be lower than 4. When water flowing through a soil meets a compaction layer, it can't get through, and so, in heavy rain, this can result in a saturated layer of soil sitting on a hard compaction layer. If there is an incline, the topsoil can start to move, resulting in a landslide. This type of soil erosion is a big problem in many places around the world. So how is good structure built by the soil food web? Well, this depends on the type of soil we're dealing with. The terms sand, silt, and clay describe the size of the soil mineral particles. Sand particles are relatively big, and so are the spaces in between them. Water quickly finds its way through the gaps, and not very much water is retained, especially if the organic matter content is very low, as organic matter can absorb huge amounts of water. So sandy soils tend to be very dry and are prone to wind erosion, which is the process by which the topsoil is blown away and lost. Soil erosion is a serious environmental problem and poses an existential threat to humanity, as we only have around 60 years of topsoil left in the world, according to recent estimates. With the soil food web in place, the picture rapidly changes. Beneficial bacteria produce sticky compounds or glues, which make it easy for them to adhere to the surfaces of organic matter and sand particles. These particles then adhere to one another, forming microaggregates. Notice how as things clump together, small spaces are created around them. Fungi also produce some glues, and their long, narrow tube-like structures act like ropes, tying together the microaggregates to form macroaggregates. Now even larger spaces are formed in the soil structure. When microarthropods, earthworms, and insects burrow through the soil, they create even larger spaces like tunnels. All the while, the soil food web is increasing soil organic matter in the soil profile by decomposing the surface litter into humus and transporting it deeper and deeper into the soil. Soon you can dig down and discover layer after layer of dark chocolate brown soil, where there was once only lightly colored sand. The result is a structure that will hold water for several months after the rains have stopped, making it available to plants in times of drought. Roots are able to dig much deeper and to access more water and nutrients in parts of the soil that were never available to them before. In essence, the subsoil has now become topsoil. Dr. Ingham and her team have worked on landscapes such as pastures, turfed lawns, and golf courses, where the grass roots were only able to grow an inch or so into the soil because of the presence of compaction layers. In just a few short months after the soil food web is restored, those same roots are able to grow more than 3 feet deep, accessing more water and nutrients than ever before. In clay soils, the problems are a little different. Clay particles are often referred to as platelets, as they are kinda round and flat like the plates you have in your kitchen. Without a balanced soil food web, these platelets get stacked up on top of each other, forming very tightly compacted structures. Compaction layers can form very easily in clay soils. The solution to this problem is finding a way to get those clay particles to stop stacking. This can be achieved by a process called flocculation. Flocculation occurs when sufficient positively charged calcium ions are present on the surface of the platelets. This results in them repelling each other just like magnets do when their poles are aligned. The soil food web increases flocculation, and once this is achieved, structure can be built in just the same way as with sand particles. The result, once again, is a well-structured soil that enables plants to access more water and nutrients than ever before. For farmers, this means increased yields, cost savings due to reduced irrigation requirements, and even further cost savings as there is no longer any need to plow. Lower costs and increased yields result in greater profits. For the environment, there are a number of benefits. A well-structured soil that is home to the soil food web purifies water as it passes through the soil profile. This is because any contaminants in the water are seen by bacteria and fungi as nutrients, and are rapidly absorbed into their bodies as the water passes by. Soil erosion by wind and water are greatly mitigated, offering food security to future generations. And finally, water vapor is one of the most abundant greenhouse gases. By enabling more water to infiltrate the world's soils and to flow into aquifers, we may be able to contribute to the fight against climate change. If you want to help secure the world's soils for future generations, then sign up for the Foundation courses today.
Okay, you guys hearing me?
Yes.
Okay, great. So I'll go back to the to my presentation, sharing. Yeah. So the what we gathered basically from those videos is that in the end, microorganisms balancing or bioremediating the soil is the key. And some of the tools to do that is using mulch, using compost, basically trying to bring back the organic matter within the soil. And as that occurs, that soil biome start creating and start becoming healthy, and basically your soil start becoming more productive, yeah, of which the plant will be able to tell that, and that's where you start seeing result. But basically mulch, and this is where we're going. What is mulch? In my words, it's basically the process of covering soil surface around the plants to create appropriate conditions for the crop to grow, right? And this can be done two ways: an organic way with organic material, with mulching material that is basically I'll show some examples right now. And another way is with plastics. But within this presentation, we won't get into the plastic part, simply because we are dealing with organic agriculture, and we want you to understand that there are ways and means to do that outside of just the plastic if these organic material are available. But there are many reasons why we should mulch. 10 of them I would like, or maybe I should probably have a little interaction here where you guys could open your mic and let's see why do we mulch? What are some of the reasons you guys believe we mulch? Remember what it is. It's actually the covering of the soil, practically the covering of the root area of the plant. And there is a reason why you do that. And so one of them, for example, which most people would think about, it's a source of weed control, right? And you all know why having that layer of mulch around, there is no light penetration to the soil, because that is needed for any sort of seed to start germinating, including grass seed. So that's one. And somebody else say, let me know what is another reason why we mulch.
It helps hold the water in.
Perfect. That's one, help hold the water. And that is very important, as you heard about the structure, what's the importance of the water, right? So this is where that tool comes in. The mulching help in terms of maintaining water. For example, depending on what type of soil you're on, you mulch, you have respiration due to the microbes and the organisms within the soil. And as respiration occurs, these gases go up. But if you have mulching, what happens as heat touches as a cold air touches heat, it basically traps water. And so that's certainly one area. What would be another area?
It helped to create nutrients for the plant.
Exactly, as it decomposes, right?
Yes, sir.
Good. Maybe two more from somebody else, another two person. This is after the fact, no? But reduction in the cost of fertilizer, as you note, one way, because as mulch decompose, it creates nutrients. That's one way, but also it provides shelter for microbes to do the things that they do, or the microorganism, the microbiome within the soil. And as they do what they do, as you heard from the first video, they basically start allowing for nutrient to be captured and nutrient to become available within the soil. And if they come available and are used at the right time, the plant is able to absorb those nutrients, right? And if the plant is able to absorb those nutrients that becomes available, then less fertilizer is actually used, and so therefore reducing costs. And with all of that occurring, obviously, the produce start improving because the plant is getting the nutrient at the right time in itself. Another big area in terms of why we need to mulch is, again, reduction in soil compaction, right? The more that tractor, the more you walk, the more the animal walk on that bare soil, it start compacting, right? But when you have this layer on top, actually you're transforming the soil there. And so we start seeing things occurring there. Reduction in root damage, again, another issue. It helps to control soil erosion, as you saw earlier. Salinity management, that's a big deal in areas that are near the sea and you have salt. Again, mulch help in that regard, because it traps water, and water moves salt to the bottom of the soil layer. allowing for the root to be free of those soils. So that's one management technique. It's a source of pest control again. And obviously the big one is it create a soil microclimate that allows for microorganisms to work. So being one of these tools, the issue of mulching is very, very important. Right now, we are doing trials in the banana industry here in Belize using processing waste that they would normally throw away, or field waste that they would normally cut and then remove because of sigatoka and other disease that could become an issue. We are basically using those as mulch, of course, applying microbes within the within the root area of the plant, and these allow for creating that microenvironment uh, where we are seeing actually the soil physical nature is beginning to change. These are very compact soil, and we are noticing that areas where we are doing this work, there is even better water filtration in this area compared to before, right? So that helped. Another thing that is going on here as well is that we are able to also reduce nematodes population using mulching, right? This is in Peru, in pear, right? They are using grass. If you know, they grow. They have a row of Bermuda of switchgrass, and this is what they are using. They are cutting to be able to create mulch. If you know, they are doing it on the young plants. If you look at the large plant, there is a lot of shade, so there isn't need for a whole lot of mulching there anymore because the shade is providing the canopy is providing the shade, allowing for that soil for temperature, not for the sun. Hello? Yeah, for for there not to be direct sun. And so in the case of small plants, that's where the mulching occurs. It's a great technique and it's working. Obviously, our EM producers, this is the time that that they use as well to apply EM just before the mulching occurs. And this also protects the microbes during this time. And these are large fruit plantation, but these are just some techniques that are used. As well in papaya, many of the waste is just gathered around the root area as well. And that's where the microbes are applied as well. But definitely it's mulching that is being done, because these leaves fall, they also control them so that you could have space to move. But these are some of the things that happen. This is what we are doing in sugarcane as well. And this is in order to stop that second burn, but there are many other things going on here. We are actually mulching. We are actually taking, after green cane harvesting, we are actually putting back those green cane in the center between where you have the regrowth of the plant occurring. As you could see, we have improved microbial growth within that area in terms of mycelium from different fungus. Reduction in weeds occur there, and obviously improving the soil organic matter as these mulch decompose. This is in Colombia, in sugarcane residue as well. Of course, here there's a trial that they are doing, but this trial basically resulted in showing that you can reduce fertilizer use within a year or two by 50%, right? And so now many who are doing the green cane harvesting are using the technique simply to be able to reduce. And they are also using the vinasse, the waste from the rum factory, as a source for potassium, but it also brings different microbes to play. What they are doing is basically bioremediating the soil, along with EM and different trichoderma and different microbes, and allowing for that soil web to be created, and allowing for the plant to have all these other characteristics. So in terms of mulching, these are the things that actually can occur if you have the resource available. It's best to use it, because mulch, the major issue is to create that microclimate below, and certainly to reduce the sun rays from hitting that soil. Direct sunlight, then you tend to kill off most of the microbes on the top. Not to say that they are not there, they are still there, but they are at the bottom layer. But once you have the mulching, then it allows for the whole dynamism or the whole cycle in terms of that nutrient decomposition and movement. So we go to the other area, potting mix. People talk about potting soil. Basically, again, what is it? It's a soil or a soilless medium used to grow potted plants. That's basically what it is. And normally, this is done to avoid waterlogged soils. Like you don't want to grow that seed or that young plant right there in the waterlogged area. You want to put it in a potted medium before, for it to help it to grow without diseases, to give it a chance, no? And then with the management that you're doing there in the soil to allow for water to move, then you bring back that. But in a nutshell, that's what it is. What you do as well is to control the soil texture and structure, and that's very important, because in potting soil or potting mix, that's what you want. You want very aerated soil. You want soil that has less pathogenic microbes. You want soil that has the ability to retain moisture, but not to have it there forever, or else that seed can rot. So the whole idea is to get that first 15-30 days of that plant to allow for root structure to occur. And as I say, there's potting soil, which is actually using soil, and they're the commercial potting mix that is basically sterile and doesn't have nutrient or anything, but it allows for moisture, and then you could put in your Miracle Grow and your other nutrients that are needed. In general, when we are talking a potting mix, as I say, there are basically 3 things or 4 things that you really are looking for whether you are designing it yourself or whether you are buying it. You are looking for a mix that will allow for germination rate in excess of 90%. If you start having less than that, then it's not a good potting mix or a soil mix, no? You want one that basically doesn't allow for fungal disease development. But very important as well is the ease or challenges with removal of seedling from the tray during transplant. That is another area that is very important. And of course, that the mix will be able to retain moisture. The traditional or classic soil-based mix that we know about, and this is classic worldwide, 1 part peat moss or 1 part mature compost, if that's what you want to use. In place of peat moss, you could use coconut coir, right? And that's 1 part. You could use 1 part also of what we call here in Belize black soil. Of course, you would want that it doesn't have pathogenic microbes, but the reality in Belize, most of black soil that anybody is buying or getting uh, are not sterilized. But we have a solution for that. Add EM to it. EM will start reducing any pathogenic microbes within that soil, but also present itself with very good microbes that are actually liberating gibberellic acid or indole acid, which are root growth hormones, which are very good for potting soil or potting mix, right? So by using EM within that black dirt, that also help you there. And of course, one part of clean construction sand. It's the sand that the guys use to do construction, or perlite. Perlite is actually if you buy a commercial potting mix, you see some little white stuff in there. That's actually perlite. It's basically volcanic glass. That's what that really is. It's neutral. It's very light, and it's porous. So it's very good in holding moisture, but it also very good as increasing the surface area for beneficial microbes, right? If they exist, but it also increases the surface area for pathogenic microbes if you are doing nothing about it. So it's always important to try to sterilize that soil or sterilize that medium, and do it with some fermenting microbes that such as EM that will help. One, there is a Cornell mix that a lot in the US use. Several people here in Belize I see adopting some of these. And these are the two I'll talk about, because this one here is more adapted for organic growers. And basically what that is like a half cubic yard of peat moss, or the coconut coir again, half cubic yard of perlite. Let's say if you don't have perlite, then let's use the sand, the construction sand. 10 pounds of bone meal. I know in Spanish Lookout area, there was a place that was doing a lot of that. But we can always end up, if you could find that, you could always do that. That's a lot of phosphorus coming into the mix. 5 pounds of ground limestone, right? I would go with dolomite limestone if possible, but ground limestone, and blood meal. Again, this could be anything. Here you're talking about nitrogen, we are talking about phosphorus in blood meal as well, no? Or animals that you slaughter, the blood is there. We could use that as well within that mix. Of course, all these things, if you're not careful, it could come with pathogenic microbes. That's why we always say add EM to it. And for for every 100 pounds, a liter of EM agriculture will do well. This here, the Ministry of Agriculture, very interested in this area because they have been looking at ways to see, because not everybody could buy that potting mix, right? And so they have been doing, last year they did a trial, which I am privy to that information, where they are looking at the same black soil and sand. If you look here, we are talking the black soil, sand, and chicken manure, black soil, sand, and what is very much available in Belize, sargassum, black soil, sand, and humus. And this is actually lumber compost, right? And then this is a germinating mix. This is one of the actual better germinated mix in Belize. So that's the one that they use as the control. We know it's very good. It has a 98% germination rate capacity. And so that is what we look at all of these. We look at 4 different vegetables: sweet pepper, tomato, cabbage, and lettuce. 18 plants in each tray, and per rep, per treatment, and we're analyzing those. No, if you know the the black soil, half part sand and 2 parts sargassum work very well. It's over 90%. We also certainly saw that the black soil, sand, and any of the humus are above the 90% as well. So those are 2 areas that we believe certainly can work well within a potting mix. It's an issue of looking at the cost to see how that is compared to the germinated mix. But what we are showing here is that there are ways to do your potting mix as well. And as I say, there are many other things that we could do, but I'm just showing some of the ones that are going on right now, and because of the different ways that exist. A lot of people are always amazed at, okay, why is the one with the chicken manure poor? Uh, this one is obvious. This certainly is an issue of the age and the maturity of that chicken manure. You have a very young chicken manure, which means it's fresh. You will have burn, and as well high nitrogen in the form of ammonia will suppress seed germination. And so that's probably the case, almost certain that that's the case why the chicken manure. Now, what we have done as bio, uh, we have been using EM as well in chicken barns, and what we have noted and tested, that manure within 2 weeks, or say that manure that comes directly out of that chicken barn where we are using EM, within a week you could practically use that within your planting area without burn at all. But if you get chicken manure, normally you would want to rest it for at least 4 weeks, almost a month, before you could start using it. I can assure you, if you get that chicken manure, here in Belize, they normally sell them by bags. 1 bag of chicken manure, you mix that with 2 bags of black soil and 1 liter of EM, I assure you, you will be able to use that manure, be it fresh as is, you'll be able to use it within 1 week without any burn, between 3 days to 7 days without any burn. And we have proven that, we have shown that repeatedly in sugarcane as well, that it's possible there. So that's where we are in terms of in terms of the issue of potting mix. In terms of compost, what is it? All right. Again, decayed organic material used as a plant fertilizer. That's what compost is. Today, I won't go into detail with how we make compost. As you know, time is very fast, and I expected that to occur. This whole thing we could do. Vermicompost, again, this is another issue we could take another half an hour to an hour to discuss. EM compost, the same thing. But I will just present some data, and then we'll show you how to do the last part, EM Bokashi. All these are considered compost, no? And so we'll look at that. Some data, for example, coming out of here from Agriton. These guys are from these are the EM producers in Netherlands, looking at traditional versus EM compost. As you know, the EM compost is a fermenting compost, anaerobic, without oxygen, without air. And what is important is that it's the use of EM. So when we are looking at that, this gray area is the conventional way, and this blue green area is the EM way. If we look at turning frequency, these are data that we know. 1 to 2 times a week, the same thing you will do in the EM compost, right? We are just comparing these two. In terms of when it's ready to use, traditional compost, depending on what you're using with it, uh, and the temperature itself and how high that compost was when you started, we are talking anywhere between 3 to 6 months. EM compost, within 2 to 3 months, that's ready to use. What is important in the end is what is produced and what is available to the plant. You know, you have ammonia very volatile as well, right, in the form of gas. You have carbon dioxide, again, very these are carbon moving or released through the air and not necessarily going back within the soil as you would want for a compost to do. While with EM compost, these carbon are converted to organic acids, right? These ammonia are converted to nitrites, and these are available to the plant. And so if we look at the work that was done by Agriton, you look at the temperature changes in terms of these windrows, you have increase in temperature and eventually that start going down. That's always the case with any normal compost. In terms of the fermenting compost, this is a bit strange here for the data that they have, but normally you would have an increase. The increase more than likely occurs within 3 to 4 days, and then it start tapering off. But because I guess they were testing every 7 days, they probably not saw that, no. But definitely there is always an increase and it drops. Any compost, you go through that hydrothermic area where temperature increases and reduces. But what is important is after a while that compared to regular compost, and this is where you due to the fermenting microbes within the EM that cause this to occur. But importantly with that, when we are looking at the data, right? And this is very key. Remember in the beginning with the video, we are talking about losses of material from the Bokashi renewals versus a traditional compost. And I bring out these data because to show, if we look at EM compost, right, or EM Bokashi, basically what is important is the amount of organic matter loss. Very minimal in terms of these composts. They did it in 2013, they did it again in 2015, and you see the loss of organic matter is very, very low compared to traditional compost. You end up losing almost 50%, 49, 48 respectively, of the carbon as that compost decompose. With this whole climate change issue, what we need is for that carbon to go into the soil. And so that's why it's important to be looking at compost using inoculating with microbes instead of just having it naturally do decomposition. But carbon loss, again, we look at that. The carbon loss is very high. Nitrogen loss, compare using Bokashi and traditional compost, we have a high percentage. And then in the end is the carbon nitrogen ratio, the CN ratio, which is very important in determining determining your a good compost, no? Importantly with compost, for you guys to understand, if you have a soil that is deficient in nitrogen and you have a compost that its CN ratio is above 20, what you tend to do when you put that compost on, or you tend to have mineralization, right? You basically, what start happening is that you find out that the microbes start consuming the nitrogen within the soil, right? If it's very high, the CN ratio is high, start consuming the nitrogen in the soil before the plant uses it. And so you really need to be able to check your soils when you're using these things. But if you have your compost in the range of around 18 CN ratio 18 20, it means that compost have high nitrogen, and so the microbes will not be consuming nitrogen that is within the soil. And so basically the plant continue removing nitrogen that start becoming available. There is always that delay if you have very low nitrogen within the soil or within the compost, where the microbes end up using that to start growing and developing itself within the soil. So that is important to note. That's just a asterisk that I wanted for you guys to understand there. This is 6 weeks after fermenting. The traditional compost, how it looks, and the EM fermenting compost almost look the same as it was before when it started. That doesn't mean anything. What it means that this now, when it goes out into the field, it start decomposing this way. But what happens then, by that time, all the nutrients are being released within the soil. So the plant is able to capture it. That's basically the difference. When you put this out in the soil, you lost most of the nutrient from this. While when you are putting this guy out in the soil, most of the nutrients are still there for the plant to absorb and to use. Now, household solid waste compost. This was a trial done. I just pulled this data for you guys to see in Tanzania. This was done in 2016. Again, traditional compost, EM compost with chicken manure, and EM compost by itself. Again, the CN ratio, they're very low. This is all depends on what you're using, but important in this issue is always what we want to look at is the organic matter percentage. That is very important because that's carbon. That's basically carbon going into the soil, right? And of course, if you look at the potassium and the nitrogen, that's higher in the EM compost as well, right? Just wanted to show you guys that. So now that's my area in compost. As we go into EM Bokashi, this is where we will do a quick 10 minutes of how to make EM Bokashi and how to use it within the household, using household organic waste. What you see there, the photo, this is EM Bokashi that we make. We make that and we sell that. We'll show you actually how to make this stuff. And in the end, you will be able to do this, no? How we make this and how it's easy for you guys at home to do this is certainly the material needed is rice bran, rice hull. The one that we have, we don't have rice hull in it because we don't want it bulky. We want the you guys to be able to use it. You could add rice hull to it if you want to improve in terms of the aeration and the space, especially if you want to use it within your potting mix and stuff. You could add rice hull to it. Molasses, EM1. Most of you guys know EM agriculture, but we also have EM1, which is a much higher concentrated product with microbes. Water, garbage bag if you have, and bucket. So those are what we have. And just give me 1 minute to set up and convert back to that's our EM1. And I will stop basically share here because this is where we are looking at the practical component. If you note, Miss Karen, there is 2 William Usher within the area. Would you be able to put the other William Usher there as co-host? Because I will be using the video camera from the cell phone there.
Yes, just a second.
Okay. So I will stop share here for now. Everybody is good so far? I know everybody is quiet, but everybody is good. All right, good.
I have a question, sir.
Sure, go ahead.
Depending on the plant, does it require a specific amount of mulching?
Sorry? Can you speak a little louder?
Depending on the plant, does it require a specific amount of mulching?
Mulching, as I say, mulching is just an issue of trying to cover the soil where the root area of where the soil is. It's an issue of availability, but definitely the objective is to cover the root area of the plant. That's basically the objective. Okay. Hello? Okay. I'm setting up. Give me 2 minutes to set up.
He's doing another switcheroo.
Okay, everybody, while William is setting up, I'll kind of show a little conclusion slide that we do at the end usually, but while he's setting up, just to announce our speaker for next month, basically, will be something that I think a lot of people might be interested in. And I'll also put this slide up toward the end. So it has William's email address, his website at belizeagroenterprise.com, and his office number and his cell number. So if y'all want to take a moment to jot those down. And his office in Belize in Belmopan, if anybody knows where the old deli was from Ian Anderson, it's almost right across the street from that in a house on the corner, but he can give directions.
Okay,
And
so we are ready to
you're
present.
ready. Okay, hold on and let me stop screen sharing. I'll put this slide up again at the end to give everybody contact information for Pro Organic and to let everybody know about our next speakers meeting, April 2nd.
Okay.
All right, back to you. William, we can't hear you.
I went to his shop last week.
You're hearing me now?
He sells
Yes,
this
yes.
Okay, guys.
product.
Basically, what I have in front of me is the rice bran, right? Rice bran can be bought at any of the rice producers in Spanish Lookout, in Shipyard, in Blue Creek. In the south, you could get it from the rice factory in the south when they are doing their stuff. Rice bran is sold anywhere between $25 for a 100-pound bag and $35 depending where you are buying. No, but this is basically what will be inoculating with microbes. Remember, here there's 10 pounds. There's 10 pounds of rice bran. You could use wheat bran as well, and you could get wheat bran at Belize mills. I must say the bakers will be competing with you with it, so you might not be able to get it quite easily because they give wheat bran preference to the bakers, but it's around the same price, 25 Belize dollars per 100-pound bag. So what we'll add to this is rice hull. In this case, rice hull is actually the covering on the rice. For those who don't know, there's a covering on the rice that when you pick it from the field, you'll see it with this cover. This comes off at the factory. And then what we call brown rice, not the white rice, is that which has on the bran. The white rice, actually the nutritious part of the rice is what comes off the bran, right? And this is normally used in animal feed and in the different stuff that they do with it. So we will add as well the rice hull, because this will give some structure and allow as well for more aeration when it's used in the field, no? So that's basically what we have here. We'll mix that up. What I have on the side here, this is actually natural salt, if you have it. Not the regular salt, because you don't want iodine. Iodine actually kills microbes, so you don't want that in the salt. Kosher salt might be the best thing to use because that's more available. But actually, the red mineral salt, that is even better if you could have access to it, right? But this is just salt. We could put it in here. What I prefer to do is actually, instead of putting it in there, I just put it in the water. The water is, here we have 2 liters of water for every 10 pounds, right? I put that in the water, right? And I'm supposed to have a spoon around somewhere to mix. Just a minute. Yeah. And this water here, it's warm water. We want warm water because this helps as well in terms of the diluting the molasses, no? 40 milliliters, sorry, 40 milliliters of molasses. What I normally do, I would take this and I would add the EM1 to it, because the EM1 is very acidic, and that helps in terms of the quick dilution of the product, no? So we'll take that and add another 40 ml to the molasses. I mix that up to get that mixed well within. Put that in the warm water. Again, mixing up very well. So here we have the salt. It's normally like 2 tablespoons for every 10 pounds. 40 milliliter molasses, 40 milliliter uh, uh, of the EM as well. And this is basically what we pour into this mixture, right? And we just simply mix this until all the dry rice bran becomes, right? So this basically we continue to mix and knead and mix and knead till everything that looks dry basically becomes. At our plant, when we first started, we were doing this the same way, doing like 10 bags, 20 bags. Of course, it's hard work, I can tell you. But the easiest way to do this is with a cement mixer, right? Much easier. When this is all done, get this done quickly. But you won't need any more water than that. It's sort of like when you're kneading bread. The same thing you are practically doing. But what the key to all of this, when you know it's right, it has that 30% moisture within it. Remember here we have the microbes, we have the food source, we have the molasses, right? I will just basically leave it like this, but we need to continue doing it more so that it doesn't leave with a lot of clumps, right? And in the end, once you could hold it and it forms a ball without flaking off, that means it's done, it's right? So what do we do with this now? At home, you could simply flatten this out. Right? When that is done now, that what we have here, but what you want to do now, you want to ferment this. And so to ferment this, what we would do now is take this, just give me 1 minute. I'm turning around here. I forgot the garbage bag. This is a small one, just giving you an example of what we would normally do. And this is easier. We take the Bokashi out. We fill a bag. because it has to be fermented, right? So we take a bag, we'll take out all the air. Come closer, that they can see. We're taking out all the air. Right? Take out all the air. Take this now and put it in the easiest thing to do, an empty bucket that you'll have. You take that empty. Yeah, put this basically in an empty bucket. That's the bucket, something that is airtight. Right? And cover, because you don't want light, you don't want air getting in. And this basically will ferment for 2 weeks. You leave this here for 2 weeks. Don't bother with it, just leave it there. When you come back, you basically will have a product that looks let me see, show you here, a product that looks like this. We normally pull it all the way to the top, that you could squeeze out all the air. We'll normally have this like this. And from this that you see here, from this that you see in my hand, you basically get this, which is the Bokashi, right? This product is finished. This product we just prepared. And this takes 2 weeks. And once you keep it there, you will have absolutely no problem with that product. But when you're ready for it, you will note that it's tight. You'll have to take it out and basically break it up and sieve it depending on the size that you want, to basically come back to this particular product, which is the Bokashi. If you look at it, we have it sieved very small, thin, as you see that there. That's what we are looking at. And this is actually the product. Now, because this is agriculture, we are using this in the agriculture field. You can do several things here. You can put in activated charcoal, right? Within this mix, if you want that, right? You could put the perlites that we spoke about in there, and stuff like that you could put in here, because it ferments and it's agricultural use. It's for the crop, it's for the soil. But if it's for livestock, because this same Bokashi, you could use for livestock consumption. Of course, there are certain things you will not include in there because it's for consumption, no? But the product that we have would just have the rice bran. It have azomite. It doesn't have the charcoal, because we have a product that has dual use, right? For both livestock and for crop. But you could put in all the other stuff even within this product, you mix it afterwards when it's finished and ready to go. So that in a nutshell, that is how EM Bokashi is made. So what I'll do now is show you how we use EM Bokashi, right? I'll put these stuff away. We'll fix these later and do the fermentation afterwards. Okay. So what do we have here? What you see here is a EM Bokashi bucket. This is a commercial EM Bokashi bucket, right? This bucket has a seal cap, right? Comes with a masher. I'll tell you why. And it comes with a middle that has hole that is perforated. That normally goes within the bucket, and then the bucket has an opening that you can open to take liquid out of, right? So basically, you're at your home, or even in the garden, or in your yard, when you have that waste material, all that food waste, etc. What you'll be doing, you'll be putting this sieve in the bottom. What does that look like? This is a commercial bucket, right? Now, a commercial bucket like this will cost in Belize almost $200, right? Most people will not even bother or want to do it. We brought this in so that the hotels could start using them. Excuse me. But what's the trick? Here is my local Bokashi bucket, right? My local Bokashi bucket is basically 2 white pigtail buckets. There is one here, right? You could put a perforation on that to have a little nozzle that liquid could come out. But this bucket that goes in the bottom doesn't have any hole. While the bucket that goes inside, this bucket will be perforated just like this. To have all the holes. So with a nail and hammer or with a drill, you perforate the bottom of this bucket, right? That's what stays in your kitchen or in your garden and sits there. And basically, you put all your food waste, your vegetables, and all that stuff in there, right? Remember, that is in the perforated bucket, and the perforated bucket is inside the other bucket. The concept is the same thing. The commercial Bokashi bucket, the bucket that doesn't have perforation, and you have the perforation that is there. So all these feed would go in here, just as within the local Bokashi bucket. Now, on a daily basis, what you will be doing, basically, this is where the EM Bokashi comes in. You will be taking on a daily basis when the person finished cooks, you'll will basically be coming for your bokashi. Just basically 1 scoop. If you have a sausage can or a cup, a coffee cup, that's basically what you will be taking, and you will simply be putting that throughout the food waste, right? And in the end, at the end of the day, if you have something, you could end up using just so that you're not playing with the garbage, right? You could use a gloves or a plastic bag if you have that at home. And this is just to allow for you to push down, because what you want is for as much you want to cut the food or whatever it is, cut it as small as possible, because what you want is for little air as possible to be there, right? So you'll be pushing that down, then you add your Bokashi, right? And then with your cover, or with what you do in the case of the Belizean style, you just put your plastic bag over it, right? And you cover back your bucket until the next day. You will do this until your bucket is full. When your bucket is full, you leave your bucket, you rest it, you let it ferment for 2 weeks. During the period you are putting this in there, you will find out that liquid, as it's fermenting, liquid from the fermentation of the organic matter inside are beginning to go through the perforations and going into the second bucket. That's the purpose of this faucet on the commercial bucket. You release that, you collect your liquid. That liquid have amino acids, all the nutrients from there. It has microbes as well. And so you will take that liquid now, right? For every 100 milliliters, or say a full cup, you put that in a gallon of water, and you go and you spray that around your plants. You spray it around the root of the plant. You put it in your compost. You could do that as well, but you basically have a liquid fertilizer, just going and using that. Now, after the 2 weeks of this resting, because from the time you start doing this, liquid start going. So you could always lift up your bucket probably every 2 or 3 days to see how much liquid is in there. The same thing you do, empty it in something, and you go and use that. You bring it back and you continue filling until it's full. When it's full, that's when you leave it for 2 weeks. After 2 weeks, what is in there now, you will take that. That's Bokashi, right? Fermented organic material from your kitchen. You will take that now and bury that next to your plant, within your plant rows. It's a compost, right? It's Bokashi compost. In a nutshell, that's how Bokashi is made and how Bokashi can be used within your house, within your household, to deal with any organic waste for your gardens around. And it's fully organic and you don't have to worry. In a nutshell, that's this part of the presentation. And I basically am open for questions if needs be at this time. Let me get back on my computer. I will share my screen again. Okay. Are you guys hearing me? Hello?
Yes, yes.
We
Yes,
can-
you can.
Okay. So basically the EM Bokashi at home, that's what I was showing you. You could use the EM Bokashi. Oh, I forgot one thing. Uh, with the EM agriculture that we have, if you don't have the EM Bokashi, you could you could do you could use the EM agriculture, put on a sprayer on it, and basically spray within the garbage as well, right? Within the organic bucket, you can spray, and that will eventually do the same thing, because the idea is to put the microbes on that. There will be no smell. EM doesn't create an odor. There will be no flies once it's managed properly, that you're spraying on the EM or putting on the EM Bokashi, or you could put both of them, because the EM Bokashi come with nutrients as well from the rice bran, right? And that would have a lot of micronutrients that also goes into the mix by the time that EM Bokashi compost is finished. We have all the nutrients from that area. So in a nutshell, that's the EM agriculture. You could find that on all the stores that Rima's Female, all the Rima's Female stores, sorry, or at our office here in Belmopan. In a nutshell, excuse my coughing. When I speak very long, that start happening, and I have no idea where my water is. But in a nutshell, in agriculture production, the benefits of EM technology, which is the benefit of compost, the benefit of mulching, you are able to maximize the conversion of organic matter into soil humus. You are able to help improve soil structure, porosity, promote soil aggregate formation and soil compactation resistant, improve seed germination and root growth development, increase nutrient availability, as you're seeing, of course, improving the crop quality, and more importantly, reduce soil-borne disease, improve beneficial microbes, and eventually, this will eventually reduce your operational costs, whether it's a garden or whether it's a commercial agricultural production. So, guys, I hope I didn't overstay my time, but I certainly want to thank uh, you guys for listening, and thanks to uh, Pro Organic for inviting me again to discuss. As I say, we could get into the detail with compost and other stuff for another time. But I don't want to bore a whole lot of people with that, with those parts, if you don't understand, or you don't want to understand the technical component of it. That's our website. You could find other information from our regional website at emla.com. all our products can be found within those areas. I am now certainly open for question.
We had one or two questions in a bit ago. Let me see. One was, you said that animals compact the soil, but forestry practice advocates animals, especially cattle, because their hoofs aerate the soil.
Yes, that's very true. Nonetheless, animal will compact the soil under monoculture agriculture, right? If you are not managing the soil well, and you have that soil exposed to the sun with those hoof crossing through, then you start having problems, especially if you don't have enough cattle. And this is one of the things, a lot of time they say, but the cattle will compact the soil. But if you have enough cattle per acre, you have enough feces. And having enough feces allows for improved organic matter on the soil. And if you have good management where you are rotating those animals, then you don't have that compaction. But you tend to have compaction in large, extensive areas where there are not much rotation and not proper management of the land where the cattle is. But definitely under the agroforestry, that happens because you have the rotation, you have legumes, you have other trees and all these things that are playing a role in also developing the soil at the same time.
Okay. If anybody else has any questions, just go ahead and send them in the chat session, or you can just ask William, unmute yourself and ask him, or send it in the chat session and send to everyone so he can see it. We did get a couple of comments that such excellent information and greatly appreciated, and great presentation.
Thank you.
But thank you, Mr. Usher, for releasing it.
That was sent to everyone.
EM Bokashi, I see a question. Where can we purchase EM Bokashi? Currently, you could purchase that only from our office. You could call us. We can always make deliveries when necessary. We have them in packages of 1 kilogram, 2.2 pounds, and that is $10 for that package. They say you don't have to use a whole lot of it, and you could mix it and do other stuff because it's made with EM1 and it's real concentrated microbes with it. Someone say they are trying to speak, Mr. Tony Sierra.
So Tony, you're unmuted, so go ahead and ask your question. You think your microphone's not working. Do you want to type in a question? Okay, and somebody asked, how thick should the mulch be?
Yeah. Someone asked that before. The mulch is an issue of protecting the soil. So long as you are able to not see the soil, that's what you want within the root area. Doesn't have to be very thick because in time it will decompose it. And so it's not that you'll do mulch and you'll just do it once. You'll have to come over and keep covering, because the whole idea is to not allow for the soil to be exposed to the sun's ray.
Should do it with chickens. Tony's down there.
Yeah. So William, there's a question for you about the compaction in chickens.
Compaction. Okay. Compaction is the weight of animals. So would this be less effective with, let's say, a chicken? Is less effective or having less negative impact if you're using chicken? Certainly, chicken weighs less and chicken always scratching. So you tend to have certainly less compaction. There's not a big deal with compaction. Animals, it's more the heavier animals like cows. And practically, that's really the big elephant in the room in a sense. And Tony is asking, I saw you had the EM in a bottle. I have been doing some research on the processing of growing EM. Is growing EM from natural cow's milk as effective? Okay, first of all, the EM that we have is a registered trademark official Dr. Higa's EM. We are the representative of Effective Microorganism Research Organization. That's where the term is EM is coined. So a lot of people are using the word EM. In this case, you're talking EM from natural cow's milk. If it's that would be more lactobacillus that you will be creating using EM from cow's milk, and that's almost like you're doing yogurt, for example. But yes, lactobacillus from cow's milk is a good microbe to be used. One of the things that is very important, especially when you are growing microbes, there are those mountain microbes, mountain EM that they speak about, that you have milk and you have soil that they go into the forest and pull and do other stuff. The one thing I always tell people to be careful if you are not analyzing the soil that you're pulling to know what is in there. Remember, under a forest system, that system is under equilibrium. It doesn't mean that there are not pathogenic microbes there. It just simply means that the good microbes are suppressing and keeping them at bay and allowing for that system to be in equilibrium, right? You go and pull that out. You have no idea what you're pulling. Nonetheless, you start fermenting using molasses and other stuff. There could be a possibility that you are also growing pathogenic microbes. And we have seen that in Belize. We have seen it around the world from time to time, that where people are saying, oh, but I see my crops is beginning to get more root damage, more phytophthora, etc. It's because where you went for that stuff probably had phytophthora and you multiplied it and you start distributing it. So normally you want to be very careful where you are collecting the soil sample from. That's the important part. But yes, lactobacillus from cow's milk can be used. Any other question?
Does anybody have any other questions for William? There was a lot of great information.
Normally, when there's no question, I get very scared, right? It's
Well,
it's either the presentation was so good that you understand everything, or simply, man, I just don't understand anything. I don't like the presentation. It's either or, right?
I need everybody to give me a hand of applause.
I think it was the former that you presented it very well. You gave explanations, what is, how to's, all of that. So, hey,
Very good.
lots of claps and awesome.
Thank you.
Yes, once again, you've exceeded expectations. Yeah, there's a clap. Yeah. All right, I'm gonna share my screen just for a couple of minutes here. Basically, just to let everyone know that, again, go to proorganicbelize.org, our webpage, for all kinds of information about ProOrganic, how to join ProOrganic, get active with us and helping promote healthy eating and healthy growing in Belize. It's very possible, it's being done, and just getting more people involved in it. Our next monthly meeting for ProOrganic will be Saturday, March 19th at 3 o'clock via Zoom. You can also send us an email, proorganicbelize@gmail.com, if you have any questions, general information, whatever. Also about how to get on the pesticide-free produce list, to get that weekly list. Go to our Facebook page, our Facebook group. And our next speakers meeting will be a little different on April 2nd. It's going to be via Zoom and in person for ProOrganic members. We will be going to Ashara Land Farm, which is the only lychee farm in Belize and one of the largest coconut farms in Belize.
Plus, it's a beautiful organic gardening.
Yes, and it's just the other side of Cristo Rey Village.
Yes, yeah.
Right on the road. So that's going to be, I think, a very fun outing that we can finally get out. And it'll, again, in person, it'll be for ProOrganic members only, but we will be doing it via Zoom from the farm out there. So please plan on joining us 3 o'clock on April the 2nd, Saturday. And if nobody has any other questions for William, then we will call it a wrap and say, enjoy the rest of your evening.
I have one comment.
Okay.
Yeah, one comment here. In Belize, everybody yard has grass. Right? Grass are very good mulch, very, very good mulch. The thing is, you want to be able to start cut your grass before it seeds, right? And once you start doing that, all that grass that you see people putting on the side of the street, I would just drive down every street and start collecting it. Don't let it go into the garbage. Get it? And use it as your mulch. Apply EM on it, and it works excellent. I see the city council, you always see these bags all over the place, especially when they go and do the parks and stuff. A lot of grass, and it always go to the dump. Here in Belmopan, Tony Chanona, my brother and myself, a couple, everybody is hunting down the bags that the city council would do early in the morning, because everybody know there is a major value in that. So I would suggest to you guys, start looking for them and just simply start using it. When I chop my yard, or if somebody come and chop my yard, nothing goes out, everything goes around the trees and stuff. And I just spray them afterwards, and that is good to go. That's my comment. So,
all right, thanks.
Yeah.
Okay, if no one has anything else, then we will call it a day. Thank you so much.
Thank you, guys. Enjoy the rest of your weekend.
You too, William. Enjoy the holiday on Monday.
We're all gonna be making Bokashi all weekend long.
That's right. Take care, guys.
Bye-bye.
Bye-bye.
Thank you.
I'm so excited. I'm gonna make